Solve the inequality. Write your answer in interval notation. We have a quadratic inequality. So we would start off by moving everything to one side, in this case to the left side, so that we have an inequality that's comparing to 0. We can factor this left side, and it is y times y is y squared. 5 times 10 is 50, and if they're both negative, negative 15y is the inner and outer product combination. Okay, now at this point in time, the methods are varied depending on the book. One is to go to the equation, and this then gives us two nice solutions, 5 and 10. Then we go to the number line and put those two numbers down on the number line, and then we test other values in the regions in between and to the left and to the right of these two solutions of the equation, like 0 and 7 and 15. Examples. You can pick any number less than 5, any number between 5 and 10, and any number to the right of 10. And we plug these numbers into the equation to see if they work. You can go all the way to the original equation, but if you trust your work, I like to plug back into where it's factored and 0 on one side. So 0 minus 5, we have negative 5. 0 minus 10 times negative 10. Is that greater than or equal to 0? Yes, it is. 50 is greater than or equal to 0. 7 minus 5 is 2. 7 minus 10 is negative 3. Is that greater than or equal to 0? No, it's not. Negative 6 is less than 0. 15 minus 5 is 10. 15 minus 10 is 5. Is 50 greater than or equal to 0? Yes, it is. So we get the left interval and the right interval. Now, the values 5 and 10 are actually included in our solution because we have this equal sign in the inequality. Without that, we'd use hollow dots. To form our interval notation answer, the left interval, negative infinity to 5, hard bracket, union, and the right interval from 10 to infinity. Another way to get the correct answer once you have the numbers on the number line is to visualize what the parabola would look like. This is a y squared parabola, so it opens up, and these are the x-intercepts. So the y squared parabola would look something like that. And we're looking for where is it above the x-axis or on the x-axis. And so clearly this region and this region has the parabola above or on the x-axis, again giving us our solution. If this had been a minus y squared, then it would open down. Or had it been a less than or equal to 0, then we'd be looking for where is it below. So that's a nice form, a nice method if you know the basic form of the shape that you're looking at, and we know about quadratic. Okay, the other method that is not discussed in most books, but here we have two numbers multiplying to be positive. The two types of numbers that are multiplying to be positive, either both positive, so y minus 5 greater than or equal to 0, and y minus 10 greater than or equal to 0. Both of those have to be true, so let me make that and. Or they both have to be negative. Two negative numbers multiply to be greater than or equal to 0 as well. So they both have to be negative and y minus 10 less than or equal to 0. So this is y greater than or equal to 5 and y greater than or equal to 10. 5, 10, greater than or equal to, greater than or equal to, and is this stuff. And then y less than or equal to 5 and y less than or equal to 10 5, 10, less than or equal to, less than or equal to, and is this stuff. And then we're doing an or in between. So this solution or this solution combined together, or. This method makes sense logically. It is more work. It is more conceptual. That's most likely why it's not covered in books as much. But it's an interesting thing to do. I know a lot of students like to just assume that that and that has to be greater than or equal to 0, and then they get these two answers and think that that's somehow the answer. It isn't. That's still only half of the answer, and it's only the intersection of these two that work. So clearly the easiest way to do it is to change the inequality to an equation, get the solutions of the equation, even if you have to use the quadratic formula, put them on a number line, and test the intervals that those solutions create, the 3 intervals, figure out what the final answer is. Definitely the easiest way. And it also is a nice, clear method.